In this lesson, you will learn to simplify radicals by rationalizing the denominator. Let's first look at some basic rules of radicals. So if you have the square root of 2 multiplied with the square root of 3, you could multiply the 2 and the 3 to give you the square root of 6. We can check that with our calculator to see that they are equivalent. The square root of 2 times the square root of 3, that is equivalent to the square root of 6. So we can multiply those together if they're under the radicals. So here, the square root of 4 times the square root of 4. So of course that is the square root of 16. Well, the square root of 4 can be simplified. That is a perfect square and it equals 4. So if you have a pair of like factors, we can leave that as our answer of just that factor equaling 4. Let's look at something else. Maybe it's the square root of 5 times the square root of 5. We know that that's going to equal just 5 because that becomes the square root of 25, and 25 is a perfect square, which equals 5. If we see this one, we have 3 times the square root of 2. The 3 is already on the outside of the radical and the 2 is on the inside, so we can just write that 3 the square root of 2. You would not be able to multiply them together, making it the square root of 6. The 3 must stay on the outside of the radical and the 2 is on the inside of the radical. You cannot put them together under the radical or outside of the radical, either way. So some steps in order to simplify radicals by rationalizing the denominator are listed here, and we will do those in these next examples. Let's look at example number 1. Well, one thing with rationalizing the denominator, we must make this denominator a rational number. So a rational number can be expressed as a fraction, where that fraction, the numerator and denominator, are integers, and the denominator cannot equal 1. So pretty much all that to say, this denominator is irrational currently. It is, if we evaluated the square root of 2, it would be a decimal that never repeats and never ends. So it makes it an irrational number. We need to rationalize the denominator. We need to make this denominator a rational number. So the process to do that, step 1, we're going to multiply the numerator and the denominator by the denominator number. So when you multiply, whatever is in the denominator is what you will multiply the numerator and denominator by. And notice this just equals 1. So it's not going to change the value of our problem. It's just going to change how it looks. So 5 times the square root of 2, as we just mentioned above, we just write 5 the square root of 2. 2 times 2 is 4. That would be inside the radical, but the square root of 4 would be 2. You could see this as we have a pair of 2's inside the radical, so on the outside we write down a 2. If you need to show the step of square root of 2 times square root of 2 equals the square root of 4, and that way you know where that 2 is coming from, go ahead and add that step so you know where that is, and so it makes sense. Our next step, once you multiply, you're going to simplify the radical in the numerator. So inside of that radical, if it can be simplified, you must do so. This is a prime number. 2, there are no pairs of like factors, so that cannot be simplified. We also want to look to see if we can reduce the fraction, the numbers outside the radical. So this 5 and 2, if those numbers outside the radical can be reduced, you will need to do so. Go ahead and pause the video and try number 2 on your own. Let's work number 2. First step is to multiply the numerator and the denominator by that denominator. Make sure you're multiplying by the square root of 7, not just times 7. It's the square root of 7. So we write our next step. We have 6, the square root of 7, over Well, 7 times 7 is 49. When you take the square root of 49, we just get a 7. It will always work this way. Whatever you're multiplying by should be the result of your product once you take the square root. Let's check our next step, step 2, which is simplifying the radical in the numerator. 7 is a perfect square, so it cannot be reduced. Also check to reduce the fraction. The numbers outside of the radical, if they can be reduced, you'll need to do so. This problem again cannot reduce. We can check with our calculator that these answers are equivalent. So our first original problem was, so of course if we do alpha y equals and choose that fraction option, so alpha y equals, we do 6 over the square root. So second, and in the first column of buttons, we have the square root symbol. So second square root and put in that 7. Whatever that crazy decimal is should equal your answer. So alpha y equals again. We have 6 the square root of 7. In the denominator it is over 7, and they are equivalent because we see our decimals are equal. Be cautious. This could be equivalent and not be completely simplified. And we'll look at that here in just a moment on those fractions that you need to reduce. But this is an equivalent answer to our original problem. Let's look at number 3. Again, starting the same, we're going to multiply the numerator and denominator by whatever is in our denominator. If we're rationalizing the denominator, that's why we're picking that to multiply by. And again, remembering this is a value of 1, so it's not changing what our problem equals, it's just changing how it looks. So we have 3, the square root of 3 over, well 3 times 3 is 9, and the square root of 9 is 3. So looking at our next steps, inside the radical, simplifying that radical, well 3 is a prime number, so we will not be able to reduce that, but we can reduce 3 and 3, the numbers outside the radical. They're both divisible by 3. So if you reduce 3 by 3 and 3 by 3, they become 1s. It would not be necessary to write either one of these ones. The one in the numerator would be considered a coefficient of 1, and of course the denominator of 1 is not required either. So our simplest form would just be the square root of 3. Again, we could check our answer in the calculator to see that they're equivalent. This is a great way to check your work. Alpha y equals, pick the first option, 3 over the square root of 3. That should be equivalent to just the square root of 3. So that is a great way to check your work to see that you have equivalent forms. Go ahead and pause the video and try the next one on your own. Here we again will start with multiplying by the square root of 10 over the square root of 10 because that is our denominator. So that will result in 6 the square root of 10. Remembering we cannot multiply to make that the square root of 60. That 6 is on the outside and 10 is on the inside. So we will only write it just as that, 6 on the outside and 10 on the inside. 10 times 10 is 100. 100 is a perfect square, and when you take the square root of that, you receive a 10. So let's look at our radical. Underneath that radical in the numerator, 10 is not prime. So let's see if we have any perfect square factors. Let's see if we have any prime factors that we can group together. So 2 goes into 10, gives us a 5. And then 5 goes into 5 and gives us a 1. So we did our prime factorization, and we actually do not have any pairs to make a perfect square factor. So we will leave the 10 under that radical. However, 6 and 10 can be reduced. They're both even, so you can divide them each by 2. 6 divided by 2 gives you a 3. 10 divided by 2 gives you a 5. So our answer becomes 3 the square root of 10 over 5. Again, you could check that answer in your calculator to see that they are equivalent. Moving on to our last type of problems, number 5 and 6. So let's look at number 5, again, starting the same method as we have begun in the previous problems by multiplying by the denominator, square root of 18 over square root of 18. So 6, the square root of 18 in the numerator. 18 times 18, I don't quite know what that is, but it really doesn't matter because we know the result will give us 18 once we took the square root of the perfect square. So notice our step 2, again, once we multiply, making that denominator a perfect square so we can get rid of the radical, we need to simplify the radical in the numerator. This one can be simplified. Again, we can do our prime factorization to check that. Divide by any primes. I tend to stick with the smallest, so I'm going to divide by 2, and then divide by 3, and finally another 3. So we divide by those primes until we get to a 1. I notice I do have a pair of 3s. Because the 6 is already on the outside, I'm going to leave it there on the outside, but now a 3 is going to join that. Because I have a pair of 3s, I get to write down a 3. Inside the radical, we will keep the 2. This factor did not have a pair of like factors, so we keep it in the inside of the radical. All of that is over the 18 that we had in the previous step. Let's simplify this. 6 times 3 is 18. We're going to have our square root of 2 over 18. Well, in our last step, it is to reduce the fraction. The 18s can simplify, which just like previously, you don't need those ones, and so the simplest form is just the square root of 2. Finally, the last example, go ahead and pause the video and try it on your own if you would like. Let's look through this problem together. The square root of 20 over the square root of 20. We have 5, the square root of 20 over 20 times 20. If you know that, you could write it down. However, once you take the square root, it's just going to result in a 20. Some students like to go ahead and reduce the 5 over 20 at this step. I ask that you hold off because sometimes it could cause you to reduce again in the next final step. So I recommend reducing your radical, and then with all of the factors that are out front, you can reduce the entire fraction. So let's do that now. The prime factors of 20, divide by 2, I get a 10, divide by 2, I get a 5, and then a 5. So I have a pair of 2s. Again, leaving the prime factor, or excuse me, leaving the factor that's already out there. It wasn't necessarily a prime factor, but leaving the factor that's already out there, 5, and now bringing a 2 out with it. Be very careful not to replace what's already out there. If the 5 is already outside the radical, leave it out and bring whatever additional factors out. In the denominator, we'll bring our 20 just over from the previous step. So 5 times 2 is 10. The square root of 5 over 20. And then finally, of course, we can reduce. 10 and 20 are both divisible by 10. As previously mentioned, that coefficient of 1 would be unnecessary, so you would just have the answers, the square root of 5 over 2. If you did this step back here and reduced the 5 over 20, I just want you to see what that would look like. So if you reduced 1 over 4, when you did your prime factors of 20, you would still bring out a 2, but notice you would cause yourself to have to reduce again, leaving the same answer So they do become the same, but you're requiring yourself the step of reducing a fraction twice. So that's why I recommend leaving those fractions towards the end to reduce. Go ahead and reduce your radical. Get all of those factors on the outside to be able to reduce. Obviously, if you don't need this step of showing the 1, skip it. Don't show this. Go ahead and go to the simplified answer.